Assalamualaikum and a very good day class. So now we are in week 2 part 2 video, which is still under chapter 1 first order ordinary differential equations. But for today, we'll go to the separation of variables. In this way, you need to know how to determine and find the general solution of separable equations. Now we go to the definition of separable equation. If we have a first order differential equation, we can say that it is separable if we can write that differential equation in terms of dy dx equal to gx hy. Means that here you can separate these terms, which is the independent variable you can write in terms of one equation multiply with another equation of dependent variable. Means that originally we have actually dy dx equal to function of x and y. And if this function of xy, you can factorize to get gx multiply with hy, we say that that differential equation is separable. So it is called like that because the equation can be rearranged such that all terms involving here dependent variable appear on one side and all terms involving the independent variable appear on the other side. What does it mean by this definition? It is actually when you have this kind of separable equation, when you can write your differential equation like this, means that here for this one, it's referred to, I can write my equation in terms of hy, means that this hy I move to this side, dy will be equal to gx dx. So you can see here, the dependent variable appear on one side, on this side, and the other independent variable appear on the other side. And when I want to solve this equation, I can integrate both sides. That will give us the solution of ODE. Means that here, when I integrate both sides, so I can get the solution of the ordinary differential equations. So class, we go to this example. In this example, you need to identify whether these two differential equation is separable or not. We look first for dy dx equal to y to the power of 3x exponential of 2x plus 4y. In this case, can we write this equation in terms of hy multiplied by gx? So let's resolve this one. If we have here dy dx, okay, we have y to the power of 3x exponential of 2x plus 4y. I can write this one equal to y to the power of 3x exponential of this one. You can use actually power law, which is we can write in terms of exponential of 2x. When here plus, actually it is multiply with exponential of 4y. So in this case, I can rearrange this equation such that the variable y is located together and variable x is located together. So here I will have here y to the power of 3 exponential of 4y. This one multiply with x exponential of 2x. So here you can see this one in terms of hy, function that only have y variable, and this one function that only have x variable. So in this case, when I can write in terms of the definition of separable equation, this equation is a separable ODE. So here it is separable. But for the second one, if we see here dy dx equal to 3y plus sine x. When you look at here, we are unable to factorize this one such that we can have in terms of hy times gx. So in this case, it is non-separable equation. Next class, we go to this example. You need to identify whether the following is separable differential equation or not. So we look for the first one. First one, we have dy dx equal to y plus 8x squared equal to y. In this case, I can write here dy dx equal to, I can factorize this side such that I have y times 1 plus 8x squared. So this one is my hy and this one is my gx. Means that it can be written as the definition of separable equation. So for the first one, it is separable. Next, we go to the second one, which is here dy dx equal to x plus 3y divided by x. This one, if you see, we actually unable to write this equation in terms of hy times gx. Means that you unable to factorize this equation so that it is non-separable equation. Okay. And then for the third one, I have this one. Okay, for this one, I can write my dy dx. If you see, it is quite similar with the previous example. This is exponential function to the power of 2x plus y. If here plus means that actually we can write exponential of 2x times exponential of y. So in this case, means that this is my independent variable equation and this is my dependent variable equation. So that this one is gx times hy. We can write in terms of the equation given by definition of separable equation, means that this one is separable. And then class, we go to the fourth one, which we have here sin x cos y dy dx plus 4 cos x sin y equal to 0. So in this case, I can write this equation, okay, this dy dx equal to, I move this one to this side. So I have negative 4 cos x sin y. And then this one I move also to this side, which is divided by sin x cos y. In this case, I can actually factorize this equation, whereas I have here negative 4 cos x sin x times sin y cos y. If you see here, this one I can say that it is in terms of gx and this one in terms of hy, means that for this case it is separable because we can write our equation in terms of dependent variable terms times independent variable function. Next class, we go to this example. Identify whether the differential equation dy dx equal to 3x plus xy divided by y squared minus 1 is separable or not. So in this case, we can check here. This one is separable. Why it is separable? Because for this case, I can write here dy dx equal to, I can factorize this x. Okay, so I have x here, 3 plus y divided by y squared minus 1. So I have here x times 3 plus y divided by y squared minus 1, whereas this one is my gx and this one is my hy. So I can say that it is separable equation. So this class is how you can identify whether that differential equation is separable or not. If that differential equation is separable, means that we can use the method that you will learn later to solve this kind of differential equation. So class, it comes to the end of week 2 part 2a video. You will see later how to solve the separable equation in week 2 part 2b video. Thank you.